So today we're going to look at phosphine, PH3. We are going to start off with the Lewis dot structure. We do know that phosphorus has 5 electrons and hydrogen has 1 electron. But since we do have 3 hydrogens, we are going to multiply that by 3 to have 3 electrons. So the whole total comes out to 8 electrons total. So now we are going to draw out a structure, but let me just move this down real quick. So we do know that phosphorus is going to be in the center along with 3 single bonded hydrogens and 1 lone pair of electrons to give it the 8 total electrons. Now we do know that this angle right here is less than 107 degrees, but the Lewis dot structure doesn't really show us the actual molecular structure of the molecule. So we're going to go ahead and draw the molecular structure right now. So we're going to draw out the Vesper diagram to be able to actually see the molecular shape of the molecule. So we do know that phosphine has 3 bonding pairs, as we saw with the hydrogens. And then we do know that it has 1 lone pair of electrons. So that gives us 4 pairs total, giving us a tetrahedral electron geometry shape. But because we do know that it only has 3 total bonding pairs, we know that the molecular shape is going to give us a trigonal pyramidal shape. So if we scroll down here, once again we are going to start off with our phosphorus in the center, and we're going to give it our lone pairs on top, and we're going to show our hydrogen bonds in a pyramid shape. So we do know this hydrogen is going to look closer to us, while this hydrogen over here is going to look a bit farther. So because of this lone pair, we don't know that lone pair bonding pair repulsion is greater than these bonding pair repulsion, causing this to bring these single bonded hydrogens down, making this angle less than 107 degrees. So I went ahead and uploaded a couple of photos here, as well as drawing our Lewis dot structure. So from our Lewis dot structure, we can see that it almost looks like a T. So it's kind of give us a T shape. But if we actually look at the molecular shape over here, it's more of a pyramidal shape. As you can see right here with the lone pair on top, you can see that it's not just a T shape. You can see that an angle right here is less than 107 degrees, giving us that pyramid shape. So the Lewis dot structure does give us a good job of showing us how our bonding works, but it doesn't really do a good job of actually showing us the molecular shape of the actual molecule, as we can see here. And the reason why phosphine has a trigonal pyramidal shape, we have to look at the hybridizing factors of phosphorus. So right here I went ahead and drew out the electron configuration of phosphorus, but the main thing we want to look at is the valence electrons, which we do know has 5 total, 2 coming from the 3s and 3 coming from the 3p. So to be able to bond with the 3 hydrogens, which we know have 1 valence electron each, phosphorus here has to hybridize, and this lone pair as well as these hybridize together to give us sp3. So we see that the lone pair come here, and then each electron from the 3p come down here to be able to have those 3 spaces, to be able to give it that tetrahedral. This sp3 is what gives us a tetrahedral shape. So if we zoom out a little bit here, we know that now, since each electron has a space, the hydrogen electrons here are going to go ahead and bond, and these are going to give us our 3. It's going to give us our 3 bonding pairs. And then we see, let's give a different color here. We see that we have that 1 lone pair right here. And that 1 lone pair is going to give us that repulsion to give us that trigonal pyramidal shape. So I went ahead and drew our contour diagram of our bonds here. So we saw that phosphorus hybridized to have sp3 bonds. So each one of these 4 are sp3 bonds. And then we did see that it did bond with hydrogen, with 3 of them, and each one from the electron with a 1s bond. And each one of these bonds here are going to be sigma bonds. Now we do see that we still have the lone pair. The lone pair didn't bond with anything, and the repulsion is what helps give that trigonal pyramidal shape by pushing these single hydrogen bonds down, giving us this angle right here to be less than 107 degrees. So we see that we have the 3 bonding pairs as well as 1 lone pair, giving us that tetrahedral electron shape. But because of that 1 lone pair, we know it's going to give us a greater repulsion, because we do know the lone pair bonding pair repulsion is greater than bonding pair repulsion. So because of that repulsion, we know that the molecular shape is going to give us a trigonal pyramidal shape.